everyone, today we will see 2D quiz. We have example here. We have 2D elements start from 1 to 9, but after we shift it by k equal to 1, so we have 9 come back to 1 in here. Do you see?
Anyway, baby, just name the time.
Let's make it more clear. We have a grid 2D here, and then after k equal to 1, or is it k, I can choose k is to 2 for input. Let's make our new output after shift it. So first we have to shift 1 to k equal to 2, so 1 here, 2 here, 3 here, 4, 5, 6, 7, and from this position we come back to here, so make 8 and 9. I think it's pretty simple, but let's break down some principle of this. K equal to 2, but k can equal to like 100, so it exceeds this like I think it has 9 and minus I, so k exceeds the 9, so we must find that, because after that it just like come back to when it's original. Like let's say k equal to 10 and then n equal to 9. So what if k equal to 10, 2 is equal to k equal to like 1. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 it must be come back to here as 1. So this position we shift it to this position, so it's no different. So first we must like divide, make it happen by make k equal to k, take the remain of divide by n, so we have new k. And if k equal to 9 in this specific example, so we just have returned the grid. Let's apply it here. I code by rows. I think I need to find the code. The number of code is equal to grid 0 dot length. Okay, and secondly we have the number of total element and equal to grid dot length to get the number of rows time code. Okay, like what we have here, let k equal to k, take the remain divide by n. If k equal to 0, we can easily return grid right away. After this, let's check. So we have k equal to k percent, and we need to just shift this to k. Let's say shift to k positions. We loop through from 1 to 9, so it's from 0 to n minus 1. So for each we just calculate this position, meaning the position where this shipping. So it is new I. New I is equal to, let's say, I plus k, but it's also to take the remain of n, because if we have the number here, so we plus k equal to 2, for example. This is 10 for these positions. Take the remainder of n equal to 1, so row equal to 1, take percent of 3, which is the number of code, and code equal to 1. So this this is divide, so this percent 3, so rows equal to 0, code equal to 1, which is this position. Let's apply here. Let's go. In this case, we need to make a new answer with the 2D grid equal to grid dot launch for i's in 0 to end. Answer of we must need to make a new I equal to I plus k divided by take the remain by end. So answer new I divide to scope, and secondly new I take the remains from code. It should be equal to grid I divide to code, and I take the remains of code. Okay, so let's return an answer. Let's check it. Let's see, we have the k here, we have the I here with the I inside. K here is I 32, so k we merge a choice inside to this code run. Let's see. Okay, what did we do wrong here? I misspelled it. Okay, I think we're done for this solution, for these problems. Okay, but what we here is to make a new answer, new 2D grid, so we can keep 2D array separately. So from this to this, like we take 1 and input it to 1 here. But is there any solution with the we can like have just one grid and modify it without cloning new 2D grid? We can save the memory here. We can make it revert. Like let's say we make it revert here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, first we will be reverted into something like 9 here. So we have 9, 8, 7, 6, 5, 4, 3, 2, 1. Why do I do this? Because let's say what if k equal to 1 in this example right here, so k equal to 1, we isolate this cell here. We need to move this cell into here. Let's say if k equal to 2, we need to move to cell here and move to that cell, to cell here, and move that cell on the top. Okay, so we only do move it on the top. Now let's see, we have to swap it, and this is just swap this particular, we just call it revert. Okay, we will have 3 reverts. First, revert from 0 to n minus 1. Secondly, we revert this particular should be from 0 to k minus 1. Finally, we revert the last sections is k until to n minus 1, which is these portions right here. In this solutions, I do not have to make another grid, which will save the memory. Let's implement it from iCode by rows. I need to let a grid can multiple, which means it can edit it. Grid equal to grid. Secondly, I also have to let make a code right here, which is width, zero, length to calculate the and the same length time code. But let's see, we also have to calculate the extends k equal to k, take the remain after divide by end. If k equal to 0, let's return greet, just like usual. But in here we will have something, we will have new functions called revert. We have the left side, which is usai, the right side, which also is usai. Okay, let's see, we have to input the code here with the andyanticode as C, usai, and grid. But this grid we have to make it mutations, vector code we impart it to modify it and change it to mutations, and this is also mutation because we will change the value. So in here we have y else still remain to smaller than r with the left and right. We have the function swap with the I will pass it and else and r and the code, and let's see, it's a grid. Okay, here we have else plus 1 to swap another pair, also r minus 2 1. Okay, after that we make a function with the swap. I have to do this because invert is very different when you have to like mutation your own grid, which is you have to swap, take this particular value and swap it to particular value. So let's add it in here. E else usai, also usai. So C is usai, this is the number code, and grid with the mutations vector is true. Row 1 with the first element we want to swap equal to left divide to C. Row 2 code 1 equals to left takes the remain C, and row 2 also take the right ones, and C2 equals to divide take the remain of code. Let's remove everything. We have this here. What if we want to try to change this, swap this into this? We need to divide so we can mutation this particular area, and secondly we can practice mutation this particular area. In Rust we have let's say grid dot split. I don't recall split at mutations. Split at mutation, let's say R1, because R1 smaller than R2, we can split it to R2 and return top as mutations. It's X is R1, and secondly is mut Y0. In this case this is the X, this is y. So y0 is this particular rows and x1 is this particular row. So else, let's see, if r1 smaller than r2, else if r2 larger than r1 larger than r2, we have x is equal to create split and adding mutations r1. Same here, we have mutation of y0 and mutations of x2. Let's see this example. Actually, this example is not like happening here because we will stop in this particular right when left small equals to right. But what if we like parties in right here? This is left and this is right. We have to swap it. Let's see, is the r1 and this is r2. r1 larger than r2. We split in here. We take let's see, x in here, y in here, y equal to y0 and x equals to take x out 2 with the x can here or here to cover that. With the I don't have to cover, but it's good to understand it as a whole of a function swap. At this time we just like swap two mutations by estimate equal move top and move bottom. Okay, I think it pretty much it. Up in here, let self revert of 0 to n minus 1 and see as it is code and grid with the mutation grid. Okay, 3 times with the what earlier I mentioned 0. So this is reverse 1 time, so this is reverse 2nd time, and this is reverse 3rd time. Let's say okay, finally we return a grid. Okay, in here also a sign. Okay, do we missing something? Let's just run it. Okay, let's see. Grid is like, I think spell check it on its reverse can easily help us. Cannot borrow as mutations. Change not by only mutation borrowed. But I think I return it as a mutation here. Let's see. Oh, because top here. No. We merge top equal to C1 and bottom equal to C2 with the which is like take a row here. To take it, we have to part. Oh, sorry. Oh, it's hard for me to like make it from right for the first time, but I think I done pretty well with LeetCode which I just missing the semicolons and the code here with the very rare time, because I think it's a lot of like manual doing, so you have to run it to actually address the mistake. If your IDE do not like cover it for you and the compiler do not cover it for you like root, so maybe that's why people from C++ move to root to cut the error earlier. But in root you have to like manage the memory very consistent and never let a reference empty or point to nowhere, because it do not have calculations. And this time like we have a grid, it has 2D array. We can split it and provide as a mutation from this to two area like X and Y right here, and select the exact row we need to like mutation to modify it. And finally we can swap it just like we do. Or in another language you can just like swap grid, what we have here, with R1, R2, C1 with the grid R2, C2. I personally use Java as a main job, although I am unemployed right now, but in Java you can just like doing this and it's just good to go. So I think today pretty much on it. I wrap up here. See you tomorrow. I think this is just a easy questions, but we can also learn very difficult topic like revert it and revert back to not explode the memory, so we do not have extra memory to store another 3D grid. Thank you.